Hello and welcome to this 12th set of problems on logarithm. In this set we will solve last 10 questions, that is problem number 111 to 120. So as always I'll say that when I'm reading the problem you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. So without further delay, let's get started. Problem 111 says that if n is a natural number such that n is equal to p1 to the power a1, p2 to the power a2, p3 to the power a3, up to p to the power pk to the power ak, and p1, p2, p3 up to pk are distinct primes, then show that log of n greater than equal to k log of 2. So here n is a natural number and p1 to pk are primes. So n will be natural number and these numbers will be primes only if a1 to ak are also natural numbers. The reason is if the powers of prime numbers are not natural numbers, then they will become rational and n will not remain a natural number. So now we are given n is equal to this much. So we take log of both sides. We get log of n is equal to a1 log p1 plus a2 log p2 plus ak log pk. Now this implies that log of n is greater than equal to log of 2 plus log of 2 and up to log of 2k times. The reason is that p1 up to pk are prime numbers, that is they are greater than 2. Okay, 2 or greater than 2. So, and the powers would be 1 or greater than 1. That is a1, a2 up to ak are 1 or greater than 1. So, thus we can write this. Now, clearly log n is greater than equal to k log 2. Problem 112 says that prove that log of 18 with base 4 is an irrational number. So here we write the base as 2 square and 18 as 2 into 3 square. So this square, when we remove the square, it becomes half over here. Now log of 2 with base 2 would be 1, so 1 into half is half. Log of 3 square with base 2 would be 2 into log of 3 with base 2, but 2 will get multiplied with half and will become 1, which will give us log 3 with base 2. Now 1 by 2 is a rational number, so if we prove that log of 3 with base 2 is an irrational number, that should be enough for our proof. So we'll let log of 3 with base 2 is equal to p by q, where p, q are integers. I denotes the set of integers. So from here we can say that 2 to the power p by q is equal to 3, that is 2 to the power p is equal to 3 to the power q. Now you know that 2 to the power p would be an even number and 3 to the power q would be an odd number. There is a spelling mistake here, and so the equality which we have here will never be satisfied. What that implies is our assumption here is wrong. So log of 3 with base 2 is an irrational number. We can say that. Problem 113 says that find the value of log of 8 with base 30 if log of 3 with base 30 is equal to a and log of 5 with base 30 is equal to b. So we write 8 as 2 cubed, so it becomes log of 2 with base 3 multiplied with 3. We write 2 as 30 by 15, so it becomes log 30 minus log 15, both multiplied with 3. Now log of 30 with base 30 is 3, so it becomes 3. And this becomes 3 into 5. 15 is 3 into 5, so this becomes 3 into log of 3 with base 30 plus log of 5 with base 30. Now we substitute for 3 and 5, we get 3 into 1 minus a minus b. Problem 114 says that find the value of log 168 with base 54 if log of 12 with base 7 is equal to a and log of 24 with base 12 is equal to b. So we multiply a and b, we get log of 24 with base 7 because 12 is here and 12 is here. That is in one case it is in the number and one case it is in the base. So if you multiply, both will be removed and it will become log of 24 with base 7. Now if we add 1 to both sides, we can write 1 as log of 7 with base 7. So in this case it becomes 24 into 7, that is 168 by 7 with base 7. Now 8a is from here log of 12 to the power 8 with base 7, and 5ab, we have ab from here. 5ab can be written as log of 24 to the power 5 by 7. Now, if you divide AB plus 1, that is this number, with 8A minus 5AB, we will have the ratio in denominator 12 to the power 8 by 24 to the power 5. Now, this ratio is 54. So, once we have this ratio, we can say that this is log of 168 by with base 54. So, the representation would be AB plus 1 divided by 8A minus 5B. So what we assumed with 8A and 5AB was just to figure out the base 54 for this entire formula. Problem 115 says that if A is not equal to 0 and log of A square plus 1 with base x less than 0, then find the interval in which x lies. So for both the cases, for all the cases, x has to be greater than 0 for logarithm to exist. Now there can be two cases. X is greater than 1. First case, that is, so if x is greater than 1, then x is greater than a square plus 1. Also, since a is not equal to 0, so a square plus 1 would be greater than 1. That means x is greater than 1. In second case, x would be less than 1. In that case, x is less than a square plus 1. Now, since a is not equal to 0, a square has to be greater than 0. Now, that means x is less than 1. These two conditions mean x is less than 1. So, from these two conditions, we get two different ranges for x. Problem 116 says that log of 18 with base 12 is equal to a and log of 54 with base 24 is equal to b. Prove that ab plus 5 into a minus b is equal to 1. So here we write them as ratios of logarithm. So we get log of 18 by log of 12 into log of 54 by log of 24 plus 5 into the values of a and b. Now we take LCM. Then we can split log 18 as log 2 plus 2 log 3 because 2 into 3 square is 18. So that can be written like this. And 12 is 2 square into 3. So that can be written as 2 log 2 plus log 3. And log 24 is 8 into 3. So it can be written as 3 log 2 plus log 3. And log 54 is 2 into 3 to the power 3. So it is log 2 plus 3 log 3. Once we have this, we can substitute all this here and then you will arrive that the value is 1 if you solve that. So I'll left that computation to you. Problem 120 says that if A, A1, A2 up to AN are in GP and B, B1, B2 up to BN in AP with positive terms, and also the common difference of AP and the common ratios of GP are positive, so that there exists a system of logarithms for which log of an minus bn is equal to log of a minus b for any n, find base of the system. So we let r to be the common ratio and d to be the common difference. So log n minus bn would become log a plus n log r minus b plus nd. So how this has happened is an would be a r to the power n. So a and r to the power n will be split. So a would become log a and r to the power n will become n log r. Similarly, bn would be b plus nd. So we simply write that. Now if you evaluate this, and now we write this as log a minus log d. So now you see that log a will get cancelled. So this is b, not d. That's a typo. So b will also get cancelled. So we will have n log r minus nd is equal to 0. That is log r is equal to d. So base would be r to the power 1 by d. Problem 118 says that if log of 2 with base 3, log of 2x minus 5 with base 3, and log of 2x minus 7 by 2 with base 3 are in AP, find the value of x. So given that these three are in AP, so we can write that twice the middle term is equal to first term and the last term. So left hand side becomes 2x minus 5 whole square and right hand side becomes 2 into 2 to the power x minus 7 by 2. Now we let z is equal to the power x. So this will become z minus 5 whole square, that is z square minus 10z plus 25. and if you multiply with 2 it will become 2z, and then this will be minus 7. So it is z square minus 12z minus plus 32 is equal to 0. Now this is equal to z minus 4 into z minus 8. So z would be 8 and 4. Now we have z is equal to 2 power x, so x would be 2 and 3. When it is 4, then it would be 2. And in case z is 8, then x would be 3. But if x is 2, to the power x minus 5 would be minus 1, which is less than 0, because this should be greater than 0. So we cannot accept x is equal to 2. Only x is equal to 3 is an acceptable value. Problem 119 says that prove that log of 7 with base 2 is an irrational number. So we let log of 7 with base 2 is equal to p by q, where p, q belong to the set of integers. That means 2 to the power p is equal to 7 to the power q. This is not 2. This should not be 2. It is 7 to the power q. So we know that 2 to the power p is an even number and 7 to the power q is an odd number. So our assumption that is this is a rational number is wrong, and log of 7 with base 2 is an irrational number. Problem 120 says that if log of x minus 2 with base half less than log of x minus 2 with base a quarter, then find the interval in which x lies. So you observe that 0.25 is 0.5 square. So we can write that x minus 2 whole square greater than x minus 2. The sign of logarithm is reversed because the bases are less than 1. So once we have this, we can write that x minus 2 into x minus 3 is greater than 0. That means either x would be less than 2 or x would be greater than 3. But for the logarithm to be defined, x minus 2 has to be greater than 0. So x has to be greater than 2. So once we have that x has to be greater than 2, this condition is discarded, and x is greater than 3 is what we have as the final solution. With this, we come to the end of problems on logarithm. We may have more problems on logarithm, but that is for later. So I will start doing videos on complex number now, and I hope that you have found this video useful. If you find it useful, then please subscribe to the channel and like the video so that it can reach many more students, because that's how YouTube works. The more the number of subscribers and the more the number of likes, the more it will come in suggested videos. So please subscribe to the channel and like the video. If you have something to say, or if you have a comment, you have a question, or you want videos on certain topics, let me know in the comment box. Thanks a lot for watching. Enjoy.